Hello there, and welcome back to this course. Today we are going to have our lecture 4 for this course, Introduction to Scala. So today we are going to talk about basic building blocks of this language. With basic building blocks, I mean to say those structures, data types that we are going to define, give them value, and then use them. In last lecture, we have set up Scala, and for that we installed Java. Then we have run REPL, and we have also installed Eclipse IDE, and then we have ran our very first program. So we understand everything that Scala offers. Now it's time to understand how to start with this language. For that, we will be talking about data types. So let's start our lecture objective. First, we will be talking about basic data types of Scala. Scala has almost the same data types as in Java. We have integer, long, character, boolean, then string. All these data types are also in Scala. So we will be learning about those. Then we will talk about literals. What are them and how to define them. Literal is basically how we give meaning to any type. I mean to say, if we have defined any variable, then if we want to give that a value, we will be calling it a literal. Then we will talk about operators in Scala. If you want to apply any kind of logic, or you want to add, or any kind of operation that you want to perform, you need to have some constructs for that, and those are operators. So basically, if we talk about how operators are classified, we know that we have something called arithmetic operator that has addition, multiplication, subtraction, and division. And except that, we have bitwise operators, we have binary operators, then we have other operators as well, so we will talk about them later. Then we will be talking about operator precedence and associativity. So let's start with our very first topic, Scala's basic data types. In Scala we have byte, then we have short, integer, long, character. All these data types are integral data types. Then we have float and double, and all these data types are called numeric data types. These are same as in Java, and these are kept in Scala package. Except these, we have string, then we have boolean. String is directly referenced from java.lang package. All those numeric data types, and along with that boolean is kept in Scala package. Next we will be talking about basic data types and its ranges. What is a range? A range is basically the values that we can give to any data type. All these programming languages and their specifications, we have defined, or you can say they have defined some particular ranges and the memory it takes to define any data type, and we have to follow them to program well. So we'll start with byte. As the name suggests, it 8 bits, and its range is -27 to 27 minus 1. Then we have other data types, all those Scala data types. We have short, int, long, character, string, float, double, and boolean. For short, we have 16 bits. I mean to say, we have 2 bytes to store. Then its range is, as you can see, -215 to 214. Then we have integer, that is a 4 byte, means 32-bit signed 2's complement integer. Its range we have shown here. Then we have long. Long is 8 bytes. Character is only 2 bytes. It's a Unicode character. So it doesn't support signed values. Then string, as you can see, a string, or as you know, string is a sequence of characters. So that's how we define it. Then we have float. Float's range is 32-bit IEEE 754 single precision float. So a float data type in Scala takes 4 bytes, and this IEEE 754 is a standard by IEEE specifications. And single precision means it has a very wide range, so it is defined for float. Now we have double. Double takes 8 bytes, means 64 bits, and it also supports IEEE 754 standard, and it's double precision float. So we can define more precise values. With precise, I mean to say uh, after decimal point, the number of values you can give. Boolean, as simple as you know, we have only two values, either true or false. We cannot use 0 or 1 as in binary for Boolean in Scala. Next, we'll be talking about literals. So, what is a literal? A literal is a way to write constant values directly to code. Suppose you have defined a data type as integer, but you need to have a way to give value to that integer, and we do this using a literal. So if you want to know the syntax of a literal, if you are coming from Java, it is similar to Java. If you want to define a literal in Scala, it is almost same as in Java. Only difference is that we use a val keyword instead of the data type, and that's where type inference comes into picture, that we will be talking about later in next lecture. So we know what is a literal. It's a way to define values to data types. We have learned about data types in Scala, so why don't we go ahead and try some code. We define data types and then we'll give them values. So let's start that. We have opened terminal. We will make it big. Now we will type Scala to open Scala in our terminal. See, I'm using a Mac, so it's terminal for me. If you are using Windows, you can open command prompt, type Scala. Just because we have already set up everything, it will open up. Then we will be defining some data types and we will give them values. So we will start with an integer, basic. We will write val, then an integer. We will give it a value 6 and press enter. See, the reference name you have given, it's printed first, then it is telling you the type that it has inferred, that is integer, then the value itself. Very next thing, we will be typing a long value. So for a long value, we will be giving capital L or small l at the end to tell the Scala that it's a long value. We can also give small. Next is after integer and long, you would want to create a character literal. So we will define that. It's simple. We just have to give a, press enter, it's a character. C, it's a character. Then next we will give a string. So we'll write hey there. See, it's a string. Now we have defined an integer, a long, character literal, string literal. Now we can also give Unicode values to define a character. So see, we want a char in Unicode, and we'll simply give it a name value 00412, make it a, and say it's an a. We can also give meaning like PAU 041, and 044 for DBAD. So what is this? It's a bad way to define something. And see, we use Unicode character literals, but it is taking it as a normal character. So after all these things, we'll simply want to define a Boolean variable and give it a value, true or false, as you know. Then we will try with the short and the byte. For them, if you simply give a value for short, it will consider as integer, because you know 6 is also an integer. So if you want to define a short value, you need to explicitly tell the type. See, this time it's short. Same if you want to define a byte, you need to tell byte. And as we talked about ranges, if you try to give a byte value that is out of range, Scala will tell you type mismatch, it's an integer, because byte is only supported till 214. Next we will give float and double. So first we will give a decimal value. Any decimal value that you will give to Scala, it will consider it as a double value. Next we will try with float. For float, we need to explicitly tell Scala that it is a float. For that, we will use a capital F or small f at the end. Same we can give with small f. So this is how we define float and double. Now, if you want to define some Unicodes in your string, Scala has a different constructs for you. For that, let's see. We call it a raw string. We'll define three double quotes. Then we will give, this is going to be a raw string. Simply, Scala was able to infer that you have given a Unicode character and it has taken it as a string. So what else? We have learned how to define data types, how to give values to them, and that's how it happens. Now we will go back and continue our lecture. After literal, it comes string interpolation. So what is this? Scala provides us a mechanism to manipulate strings. How we can do that? We have some constructs called interpolators. What they do is they tell Scala that the next thing that is going to be may take a dynamic value or may take an expression. Please evaluate that and put it into and convert it into a string. So how we do it? Let's see. We have this value name is equal to Raj. Then we want to print that value. For that we are using this as thing. This is interpolator. We have given a double quote, then we have wrote hey $name. $sign here works as a placeholder. It tells the Scala compiler that next thing that is going to come takes a dynamic value, so please evaluate that. Then we have at the right hand side this dollar, then an expression that is subtracting 300 minus 100. So Scala will be able to evaluate this just because it is defined inside an interpolator. So let's check what's his response. Hey Raj, you yesterday borrowed 300 rupees. I'm returning 100, remaining 200 I'll give tomorrow. So see, name was already inferred by Scala compiler, and then we have this 200 thing. Scala has three interpolators, S, then raw and F. All these works almost the same. The difference between S and raw is that S recognizes escape characters and raw is not able to. With F, we define printf style of formatting. So we will use percentage and all those things to format strings. Let's go ahead and try that into Scala Rebel. So we have our same window. We will be trying first, we will try with same example that we had there. We will give a name, so val name is equal to Rahul this time, and then we want to print that. We will start with an S, then double quotes, hey, dollar sign, then the placeholder name. You have borrowed 300 rupees from me. You have returned 100 remaining. Then we'll use an expression to evaluate. We don't want to do that on ourselves. Remaining 300 minus 100 tomorrow. And we'll press enter. And see, Scala was able to evaluate the name and the value. So this is great, isn't it? We can use it in many places. Next, we will try the difference between S interpolator and the raw. So for that, we will try a simple statement like println. As I told you earlier, S interpolator supports Unicode literals. So we'll say, or I would say, S interpolator supports escape characters. So we will give escape characters. So we have no escapes. We'll press enter and see only two escape characters are there. So S interpolator was able to recognize them. We will do the same with a different interpolator, that is raw, and it will not be able to recognize the escape character, so it will directly print as it is. See, so this is the difference between an S interpolator and a raw interpolator. Next, we will try to have an example for F interpolator. For that, we'll directly print, we'll give F, then dollar sign, we'll give it a value. Then after that, don't forget the quotes, and see, only 5 values after decimal are, as we expected, are printed. So this is how string interpolators work. But how do these interpolators work in Scala? What happens is the Scala compiler treats any expression consisting of an identifier, that is interpolator in our case, followed immediately by the open double quote of a string literal, as a string interpolator expression. And we can also define our own interpolators, but we will not talk about that today. Operators. See, operators in Scala are different than Java. In Scala, operators are methods. How? You remember we looked at this example 2 plus 3, and I told you that plus is a method invoked by calling on 2 and passing a parameter 3. The same way, every operator in Scala is a method. Dot is for a method call, I told you. 3 we are passing as a parameter. The advantage of defining these operators as methods in Scala are that we can overload those methods. So for example, if you want to add to a long value, your Scala compiler will be able to infer that long is a bigger one, so it will overload the addition operator, and the value that you are going to get is a long value. See this example. Well, long summation is equal to 1 plus 2l. So Scala compiler was able to infer that the result is going to be a long. If you see, this plus method is taking only one parameter, and that's why we were able to call 1 plus 2l. So it should happen to almost every method in Scala that if it takes a single parameter, then we could be able to write it like this. And see, we have defined a value as with a string literal hello world. Then we try to take index of o from that string object, calling a method index of, and we were able to do that. So let's go ahead and try some operators in Scala. So we will open our terminal back. So let's try simply addition operator. Then we have already used C. Then we will subtract. This is so simple for you guys. So, but still, I'm like, we have REPL to play with, so we will be playing with it. After these things, we can also divide and multiply. So these are arithmetic operators. Then we have relational operators. We can use greater than or smaller than or greater than equal to, smaller than equal to. Except these, we have short circuit operators or an and. We will try that. We'll define a value to be, another value not to be. Now we will try to be or not to be. It's true. True or false is equal to true, as you know, binary arithmetic. If we want to try true and false, that is not to be, it is going to be a false. So we can use it multiple times. We will give the desired result. So if you see this double or, and these are called short circuit operators. These operators work the same way as in Java. It only evaluates the expression if it is important to do so. Otherwise, if it's not needed, it will not. Now, after we had a look on arithmetic operators and relational operators, now it's time to get ahead and know about some advanced concepts about operators. In Scala, there are three ways to use operators. These are called infix notation, prefix notation, and postfix notation. In infix notation, the operator sits between two operands. As in this case, plus operator is in between 2 and 3. 2 and 3 are operands. In prefix notation, the operator sits at the left side of the operand. In our case, we have a 7 integer and then minus. In postfix notation, the operator sits at the right hand side of the operand. If you see, in prefix and postfix notation, only one operator is there, and that's why these are called unary operators. Unary operators takes only one operand. But in Scala, we can use only plus, then minus, and this not and tilde as unary operators. Next, we will take a look on Scala's operators classifications. Once again, we have arithmetic operators, then we have relational operators that we have already seen. The other two categories are logical operators and bitwise operators. So let's go ahead, open our Scala REPL and try these. If you are working on Windows, open your command prompt. First, we will open Scala. So we have already seen some logical operators such as and. We have seen. So let me tell you the difference between this short circuit and a simple strict AND. If we use short circuit AND, then the right hand side, or you can say the other operand, will be only evaluated if it is so necessary to determine the result. For example, this false will only be evaluated if the left hand side of the operator is true. Means to say, let's try this with an example. We have to be true, then we have not to be is equal to false. So if I put an expression is to be and not to be, it means like the left hand value, that is to be, it is true, So whatever is the right hand side value makes sense to evaluate, because if it is true, the whole expression will evaluate to true, and if it is false, the whole expression will be evaluated to false. So it is necessary to evaluate the second one. So in this case, if we use short circuit operator, Scala compiler will be evaluating both. But if we have to be and or I would say not to be, that is false already, and we have to be. In this case, just because we have false at the left side, it means that even if at the right side, if it's true or false, does not matter, it will be false. The expression will be evaluated to false. So this double AND, that is the short circuit operator, will not evaluate the right hand expression, that is to be. So it will not come to be and evaluate its result, and it will be directly giving you false. So otherwise, if you have used not to be and the strict and to be, it would have evaluated this right hand side value as well. Okay, so this is the difference between a strict and a short circuited AND. So let's go back to our lecture, and next we will talk about how these short circuit operators are working in Scala. If you know, when we call methods in Scala, we can pass parameters in two ways. One is called by value, and the second one is called by name. So this facility for delaying the evaluation of their arguments in methods, or even declining to evaluate them at all, this facility is called by name parameters. Okay, and this is what Scala uses for short circuiting operations. Next is object equality. If you know about how we equalate objects or primitive types in Java, it's almost the same but a bit different. See, in Scala, if you want to equalate two objects, you will use this double equal or not equal, but it will only compare the values of those objects. Suppose, for example, if we have defined a string that is high and we have defined another string that is also high, and we use this double equal operator, it will compare the values. It means to say what is the string value, what is the literal has. So it will evaluate that, and based on that it will give if it's true or false. But if you want to equate the object it is referring to, we can use equals or not equals. So this is how operators in Scala are different than in Java. Next is operator precedence and associativity. We have talked about Scala's operators, arithmetic, logical, Boolean, and all those. But what should be their sequence of evaluation? So in Scala specification, it has been defined the precedence. If you see, we have all these special characters, then we have multiplication, division, and modulus operator, plus, minus, then we have colon, it's a special operator in Scala, then we have equals to, not, greater than, smaller than, relational operators, then and, then XOR operator, then this or, then comes all letters and all assignment operators. So this is how Scala's operator precedence works, and this works top to bottom, left to right, if you see. But you know, Scala's operators are methods. So how this precedence is achieved in Scala? Scala's compiler has this capability to decide if a method name is starting with an operator's name, and if it is there, it will check for the precedence of that. Multiplication has higher precedence than a plus, then it will be evaluating the multiplication. Okay, same happens with all those, and this works as we already talked about, left to right and top to bottom. Then we have operator associativity. Scala has a tendency to associate these operands by its last character. Methods that and in a colon is invoked on the right hand operator passing in the left hand operator. If you see 2 plus 3, it means that plus operator has been called on 2 and we are passing parameter 3. But if a method ends in a colon, things will be the opposite. If you see the example, A, this cons operator B yields B dot colon 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 cons operator A. So this is a way we use colon operators in Scala. So it matters a lot if a colon is at the end of a method. So guys, this is what we had to talk about in this lecture. Now let's summarize what we have learned. First, we talked about basic data types. Then we talked about literals, how we give values to data types. Then we talked about operators, all these logical, arithmetical, relational, and bitwise operators. Then we talked about value and reference equality, normal, equal, equal, and not equal sign are used for value equality check. Then we talked about operators precedence, top to bottom and left to right, and their associativity. We talked about that. How Scala's operator will behave, we will check at the very last. So I would say we have practiced about how to define basic data types, how to use operators in Scala, why operators are method in Scala, and how it is of advantage to the developer community, and how it makes Scala more beneficial for us. We can overload all those methods and we can define our own. This is really great. If you see, we were using Scala REPL to check at the same time we were getting the response. So I would ask you guys to practice more and more defining these data types and get used to it, because if we strengthen our basic constructs about any programming language, it will help us out later on when we go ahead with some advanced topics. Because these basic building blocks, if they are confusing you, then it is going to be hard for you. So I would urge you to go ahead and practice more and more